Hey everyone, welcome back to my channel. So today we are going to touch upon a very advanced topic. If you have worked in any backend systems, you would have thought about scaling. You would have thought what would happen if you have millions or even billions of users like these most popular apps like Instagram, Facebook, etc. How would your application scale? How would your API scale? Now, if you've used any backend applications, if you've worked on any backend applications, you might have connected to a database, stored a lot of data into the database. And imagine you have a sign up screen, and imagine you're working at Instagram and you have billions of users, right? Imagine you want to sign up a new user, and that user is trying to look for a username. What would happen? Would you go to the database, search for that username across all the billions of rows that are in the database, and how effective or how optimal would it be? Not much, right? That's what would happen if you have lots of users. It's very easy to build that feature if you think about it. Let's take a look. So typically, a simple query like, does this username John Doe exist? And you would just run a query select star from users where username is John Doe, whatever, right? Now this seems very simple, but what it does actually is it scans through all the records in the DB. Now I'm assuming you don't have indexes right now, but hopefully you would have indexes, the right kind of indexes on the username column, and this would be much faster. But uh, even with an index, it's going to be much slower because you are going to scan a lot of records, and these indexes are also going to be super large. Or if you don't have an index, you're screwed, right? It's going to take forever to scan through a billions of rows and find out if this particular username exists. And all of this for what? Just to sign the user up, just for them to pick a username that they might potentially not even use. This is an overkill, right? So what to do? Now initially this might be okay, you might not even see a performance drop, but what would happen if you have this very large number of users that we are talking about? That's a serious problem to solve, right? So that's where something called as the Bloom filter comes in. Now this was a problem that was thought of way back, and some computer scientists and whose last name was Bloom came up with the solution. And this works on a probabilistic approach where it will tell you whether the data exists in the database or not. Now, when I say probabilistic, what I actually mean is that it will definitely tell you if the data does not exist in the database, but it may tell you that the data may exist in the database, and that could sometimes be wrong. Now, how does that work actually? So assume the same scenario where you were first initially just querying to the database directly. Now what you have is a Bloom filter. Now how does this work? This has a very small memory footprint. It has an in-memory data structure. It holds a few bits. And how does it work? Let's look into it. So how does this work? Now consider this scenario which is similar to the last one where you're directly querying the database. In this case you have a Bloom filter which you use. Now the Bloom filter itself has a very small memory footprint. It stores some bits. In this case, I just have a 64-bit Bloom filter, which is extremely small, and all it has is bits. Now I'm saying bits, not bytes. So it's one single bit of ones and zeros that will give you an answer based on probability whether your data exists in the database or not. Now, how does this work actually? Now, consider you have a 64-bit filter. Now what you'll do every time you want to query something or you want to store something in the filter, what you'll do, you'll create a hash of that value, and then you'll mod it by 64 or the number of bits that you're storing in your Bloom filter. Now this hash function, now this could be different types of hash. Usually murmur hash is what is used with Bloom filters, but that's okay. Well, let's just assume there is some kind of a hashing algorithm that we're using, let's say a SHA or a murmur hash or MD5 or whatever, right? That hashing algorithm will hash your string, and it will mod by the number of bits that are in your Bloom filter, and then you get a single number back. Now this will always return something that is between 0 and 63, right? So what you do, you take 6 and you check whether the 6th bit in the filter is a 0 or a 1. In this case, it's a 0 or it's empty, right? That means this bit is unset. So in this scenario, the Bloom filter will tell you with guarantee that John Doe does not exist in the database. Again, the Bloom filter works on a probability approach. probabilistic approach, where it will tell you whether something exists in the database or not. If it doesn't exist, it will tell you with guarantee that this does not exist in the database, but it may sometimes tell you that something may exist. It will not tell you something definitely exists in the database. It will just tell you that there's a probability of this value existing in the database. Now, how would that work? Now let's consider this scenario where you have the same value and the hashing function mod 64 returns the value 1. Now in this case, Jane Doe returns 1 from the hashing function, and you see the 1 bit is set. Now this may mean that there is either already a Jane Doe in the database, or it could also mean that there is another string of which the hashing function and then the mod return the same value 1, right? And that is the value that is set. So in this case, what you do, if you get a hit in the Bloom filter, you don't just go back to the user and say, oh, this username is taken. What you do is now is when you actually query the database. Now this is when you query the database. You check if Jane Doe exists in the database. If it does, then you say it exists, or if it does not, then you say it does not exist. Simple as that. Now in reality, this seems very simple, right? So what you need to take care of, you need to make sure that you have enough bits to handle the load, or they handle the amount of data that you have in your database. What you also want to do is, in production systems, what also happens is that you don't have just one single hash function. What you do is you use 3 hash functions typically, and they all output different values. Now what this means is the same string John Doe is being hashed by 3 different hash functions, but the mod operation is the same. So what happens is the first one gives 6, so you check if the 6th bit is unset, and then you check if the first and the 63rd bit are set. So in this case, we find that there's one hash function that returned a value for which we found an empty bit or an unset bit, but 2 returned a value where the value was set. Now because we are using 3 functions now, what we do is, even if one says that this bit is unset, then that's good enough for us to say, okay, this value does not exist in our database. This helps because if we go back to a previous example where, let's say, Jane Doe and John Doe both return the same hash value if you're using one function, but there's a higher chance of it not returning the exact same value if we're using more than one hash function. So typically in a system, you use 3 hash functions. Bloom filters typically use 3 hash functions to reduce the probability of a false hit, right? This way, now even with a smaller size of filter, you have a higher chance of not getting false positives. Now you might be wondering, okay, why do we use a Bloom filter and not a cache? Now you can build a cache. You can use something like readers to build a cache, but the problem remains the same, right? You're maintaining the cache, and then every time there's a cache hit or a cache miss, every time there is a cache miss, you go to the database, and then that is an expensive call. What we are achieving with Bloom filter is similar to that, but it's much more optimal because it has a very low memory footprint. It consumes very little resources, and if you do it right, there's a good chance that you would get a very good answer, and the error rate would be in some cases less than 0.1%. So in this video, what we're going to do is we're going to set up a Bloom filter. We're going to see how Bloom filters are actually set up, how to make them work, and how effective can they be with some real code using Node.js, and we'll see how to actually write a Bloom filter. Now this is something that I've been trying to look for a lot. When I wanted to implement something like this, I tried to look for a lot of YouTube tutorials to implement Bloom filter. I couldn't find any. Mostly I found tutorials or videos explaining what Bloom filters are, but hardly anything that actually writes some code. So in this video, I don't want you to keep looking for videos or tutorials. I'm going to solve that need for you. I'm going to show you code of how to actually use Bloom filters. So let's dive into it. Now what I have here is an already set up application. I'm going to walk you through the code that we have. It's fairly simple, and what we're using for Bloom filters is actually readers. Now readers is an in-memory database, as we know, but we are not using readers to cache the data. Readers has a feature for Bloom filters, so you don't need to build your Bloom filters from scratch. You can use readers to set up your Bloom filters. That is what we are going to do. We are going to see how to use Postgres in combination with readers as the Bloom filter, and we'll see how it improves the performance. So what we have is an Express app which just has one single route called username, and what it does, it has two APIs. One is to check if a username exists, and the other one is to create that user in the database, right? We also have this another route called fake data, which we'll use in a while to simulate a lot of users to generate a lot of data in a database, right? We'll see that in a while. But essentially, we have two APIs. One that takes a username and checks if that exists in the database or not, and the other one to actually create that in the database. Now what we are doing, we are first connecting to Postgres and Redis. Now I have Postgres running on Docker, and I am also going to run Redis on Docker. I'm going to use this image Redis. I'll copy all the commands and I'll paste it in the readme file of this code when I push it to GitHub. So what I did, I just set up Redis, which is running in Docker, and we already have Postgres running, as you can see here. So I'm connecting to Postgres and Redis that is running locally for me, and I'm going to return the connection pools for both Postgres and Redis, and I'm going to set them to app locals. Now here, if you see in Redis, what I'm doing is I'm reserving a Bloom filter under the domain called usernames. I'm calling it usernames, and I'm allowing 0.01% error rate, and this is the size of the Bloom filter. So if you see the reserve command, what you'll see, we have the key, which is a string. We have an error rate, which is a number. In this case, it's 0.01, and then we have the capacity. Capacity is, in our case, as you saw, we had a 64-bit, but typically you would need a much larger bit, but something in thousands, maybe 1000 or 10,000 is going to be more than enough most of your applications. So this is how you set up Redis and you create a Bloom filter. Now let's get into the code and look at the first API. So we have an API which is a get API. It takes a username from the query, and then what it does, it checks if this result exists if this username exists in the Bloom filter, and if it does, what are we doing? If it does, then that means that this username may exist in the Bloom filter. So we are not going to return true as it is. What we're going to do is, now we're going to query the database, and then if that exists in the database, the actual Postgres database, then we are going to return true. Otherwise, if Redis says this username does not exist, then we don't need to check anything more, or the Bloom filter says this username does not exist, then we're not going to check anything further. We're just going to return false with guarantee that this username does not exist. Okay, this is a very simple API. Let's quickly look at the users table. So what I'm doing, I have a SQL file that creates a users database, and then there's a users table which just has a simple ID and a username. So let's quickly flush this file into the database. So for that, what we need to do, I'm going to use my terminal. I'm going to say psql-u, the name of my user, which is Postgres. Let me zoom it out. Yep, Postgres, and then the host, which is localhost, and then -f, and then the name of the file, which is users.sql. If I run this, it's going to ask me for the password. I'm going to enter the password. It's going to create that table for me. Let's quickly connect to the database and see if that table is created now. Table and the database. So -u Postgres -h localhost. Yep, as you can see, we have a users table. So now I'm going to run this query to see that there are no rows in the database, in the table, right? Now what we have is also an index over here. I'm not going to create this index right now, but I will create it at a later point to show you how exactly it will affect our queries when we use it in addition to the Bloom filter, right? So for now, I'm not going to create the index on the username. I'm going to leave it as it is. Now going back to the route, let's quickly try this out. Now I'm going to use Thunder Client, which is a very cool extension which allows me to make API calls directly from the VS Code. This is an extension that I use, but you can use anything. I sometimes also use Postman. In this case, I'm using Thunderbird, but you're free to use whatever you like. What we need to do is we need to make a call to our localhost server. Let's first run the server. So I have a script called dev which uses nodemon. So I'm going to say yarn dev, It's going to start the server for me on the port 3000. So let's go back here. So this is the username API that we need to call. So username, and what we're going to pass, we're going to pass a parameter called username. Let's pass John Doe. If I hit send, you see I get false because this user does not actually exist in the database. Now let's look at the next query, the next API, which is the post API. It states the username. It creates it takes the username in the query. It sets the bit for this username, so it adds it to the Bloom filter. So this bf readers.bf, this is the Bloom filter that we're using. It adds it to the username domain or the collection that we created. So if you remember, in db-init we're creating this username, so we're going to add it there, and then we're also going to insert it into the database. The reason we are doing this first is, if you remember, that this may falsely return true. So in this case, if our Postgres query fails, this may be true, this may actually return true, but that's okay, because in our case, if this returns true, then we are still going to the database, right? So it's okay. But what we do not want is this query to work and then this to fail, and then we have a false negative, right? So we're simply just inserting into the database. We have an insert into users value, and it returns the ID. So let's try this request out. I'm going to change this to post, and I'm going to run the same query, and you see this was inserted and I have the ID over here. We're returning the response that we get from Postgres as it is, so that's what we are getting back here, right? Let's quickly verify that from the database. You see we have a new user called John Doe. Now first what I'm going to do is go back here and not make a call to readers right here, okay, and I'm just going to set this to true right now, so that we are calling Postgres and Postgres only. We're not checking if readers has this record or not. Okay, now let's go back here and make a get call and see what happens. So this time it took 48 milliseconds to go to the database and check if this record exists in the database or not. What I have is this fake data file. What it does, it creates 1 million users into the database. I'm using this library called faker. It just gives me a username. I'm creating 1 million users in the database at a time, and we're doing this 10 times. So basically we're creating 10 million users in the database, and then I'm also adding them to readers. So I'm using madd now instead of what we were doing earlier. Here we were using add. Now I'm using madd. Madd stands for multiple add, so I'm able to add multiple users at the same time. So let's quickly go to the code. Through the code, what we're doing, we have this usernames array. We're setting that to an empty array every time we iterate, and then what we're doing, we are pushing a new username into that as an object, and we are first inserting all of those users in readers 10,000 at a time. So we're doing this in chunks of 10,000, and then the reason we're doing this in chunks of 10,000 is because I've experienced that when you try to insert a lot, it throws a limit error. 10,000 seems to work. I've not experimented a lot. I've not tried if 100,000 works or 500,000 works or what is the upper limit, but 10,000 works, and that's good enough for me. So I'm going to insert 10,000 rows into the database. And finally, I have this query that inserts all the data into Postgres in one go. So I'm going to insert 1 million records into the database in one go. So I'm going to do this 10 times. So we'll end up with 10 million records. Again, this is not a lot of data. If you consider large applications, this is still okay. But for most applications out there, 10 million users is still a lot of users, right? And again, I'm running Postgres and readers locally, so I'm not going to see much of a performance difference between readers and Postgres, especially after I create that index, but it would be good enough for you to understand how does this exactly help. So I have a route created here to trigger this fake data. It's just going to trigger this function which is going to execute. So I'm going to do that now. So if you see, I'm going to change this to fake data, and this is a post API, I believe. Yep, post fake data. I'm going to call this again, it's username /fake data. I'm going to call it, and then I'm going to wait for all the users to be inserted into the database. So this is going to take a few minutes. I'm going to cut the video and skip to the point when all the users are inserted, and then I'll show you all the users into the database. Alright, so this is done. It took almost 2 minutes to insert 10 million rows into the database. Let's go back here and run account query to see how many users do we actually have. Alright, so we have 10 million and one is that John Doe user that we created initially, and 10 million rows is what we just inserted. So we have 10 million and one rows into the database, which we can now use to see the look at the performance. What I'm going to do, I'm going to select the first 20 users, and I'm going to just quickly pick any random user. Let's pick this one, and I'm going to query it, and I'm going to see how long it takes for us to get the response, for us to know whether this user exists. So I'm going to pass the username. Let's make the post get API, and when I hit it, you see reader's result is true, which is coming from here, so if it finds in readers, it returns true. So if it returns true, what it does, it goes to the database to see if this user actually exists, and if it does, then it will return true, right? So in this case, for us to know if this user actually exists in the database or not, it took 762 milliseconds. Let's try it a few more times to see how long it takes. So you see it takes between 300 to 400 or maybe 500 milliseconds, right? It's taking anywhere between 350 to 700 milliseconds. So this is a user that actually exists in the database, right? So in this case, we are making two calls. Essentially, we're checking if this exists in readers, and then we're checking if it does exist in readers, then we're checking if it exists in the database, right? So this is obviously going to be slow. We are not going to be able to optimize this unless we add indexes, which we will in a while. But now let's query a fake user. So I'm just going to add some more characters here to see if it's a fake one. Now let's try this. So now if you see, this is extremely fast, right? This is 6 milliseconds, 5 milliseconds, well, definitely less than 10 milliseconds consistently, right? So this actually helps a lot when you are querying a database, when you are checking if a user exists in a database with about 10 million users, right? So this is super fast. The reason it is super fast is it's not going to the database. Now let's try this out. I'm going to comment this part out and make it forcefully go to the database and see how long it takes. So when I try this again, yeah, see, now this is actually, I think it's caching it, but initially it took about 400 milliseconds. So it was much faster, right? Oh, actually I've not saved this. Sorry. Let me save this. And go back here. So yeah, so you see it takes the same amount of time, right? It takes between 300 to 800 milliseconds. Now, since we've established that using readers definitely helps, especially when you want to check if the user exists or not. And when I say readers, I mean the Bloom filter. We're using readers for Bloom filters. So that definitely helps if you want to check if the user exists in the database or not. Now this is a real user. I'm going to show the fake one again. Yeah, you see it is consistently below 10 milliseconds, right? So this is super fast. Using something like this, you can solve the problem where you try to look for a username. Your users try to see if a username is available or any similar use case, and they get a very quick response. So when you try to sign up on Instagram, you might have seen that it does not take you almost a second to see if a username actually exists. It's super fast, right? This is how they do it using Bloom filters. Now one last thing that I want to show is when we add an index in the database, how does this performance improve? So for that, I have this index file. What it does, it simply creates an index in the database. So I'm just going to copy this, and since I already have a connection with Postgres, I'm going to run it. You can also flush the file in the same manner that I did. In this case, I'm just going to run it. Now this is going to take a few seconds again, because remember, creating and managing indexes is an extensive task. The more data you have, the larger the overhead to maintain this data structure, right? Because index is again a data structure. So right now it's going to create this data structure for me, and then make sure that all the existing data fits into this structure, and all these existing records are indexed. So you see it's created. It took a few seconds. It's not bad because there's only 10 million rows, so it's not super bad. But if I would have done it with, like, say 100 million rows, then it definitely would have been much slower. Now that essentially also means that adding an index will slow down your insert queries, but that's okay. We have to deal with that because we want the retrieval to be super fast, right? So now with this index created, if I go back here, now this is not going to change. This is going to be the same super fast request. But if I query an actual user, this will also be super fast. If you see, it's no longer taking 500 milliseconds. It's also within 10 milliseconds, right? So obviously this tells you that you definitely need indexes. If you add indexes, you can get a performance of, as you saw, about 100 times better, right? It's taking 6 milliseconds. It was taking about 600 milliseconds. So it's definitely an improvement of the highest magnitude, right? So you definitely need indexes. So now let's try a user which we know does not exist into the database, which is like this random user with some added characters. But I'm going to comment this readers part out again to see how long it takes with the index now created, right? So again, this is super fast. So if you have indexes, your database queries are going to be super fast. But again, this is again a call to the database, right? And right now I will not be able to simulate exactly how good the benefit would be of using a Bloom filter because all of this is local. And 10 million rows again is not a lot of data to where you would need Bloom filters. If you have an index, as you see, it gives you just as good performance with or without Bloom filters. But as you keep growing, once you have like tens of hundreds of millions of rows, that's when this Bloom filter is going to be super useful. And the reason I'm creating this video and talking about it, even though it does not apply to maybe let's say the majority of you guys out there, this is a very important concept, a very important thing to talk about in system design interviews. So when you're interviewing for a senior position, if you can talk about Bloom filters, if you can talk about how you would scale your database, especially when you're applying for large companies like Fang or Mang, this is going to be a super useful concept for you to know. And Bloom filters traditionally have been something that is, it's kind of confusing to know, but I hope I made it easier for you to understand. And the most important part is I showed you how to write code, how to actually use Bloom filters in your code, and how to use them. This is something, again, like I said, I was not able to find good videos for, good tutorials for, so I tried to create a tutorial for this so you guys don't have to search anymore. So again, go back to the code, see how it works. This is very simple. You just need a few commands. Essentially readers has I think 5 commands and you only need 2 or 3 of them. The first one is to create the Bloom filter, reserve the Bloom filter, and then there are two commands. One is to add to the Bloom filter, and the other one is to check if something exists in the Bloom filter. And again, there are the mexist and madd commands, which is for multiple add and multiple exist. That's all you need to know to write to use Bloom filters in your code. And it's just this simple trick or this simple data structure drastically improves your performance without adding a lot of footprint to the memory. So this is a very advanced concept. I hope you were able to understand how Bloom filters work and you will be able to talk about them in your next system design interview. If not, use them or create something that uses Bloom filters yourself. But I hope this helps. And I'm going to push all of this code onto my GitHub page. I'm going to link that URL in the description of this video. I hope you like this video. Do like, comment and share this with your friends, your colleagues, and do subscribe to my channel so I get motivated to keep making such videos that help you guys to become a better software engineer, especially if you are a senior software engineer. Thank you. See you soon. Bye bye.